In a continuation of our lesson from last week, we are going to be solving trigonometric equations. So I'm just going to start this note off kind of with a very similar example to last week, basically the exact same. And so we're going to be plotting the point -3, -2. So that's going to be about here. And I'm going to be drawing my triangle. Remember, it needs to be drawn with my x-axis right there. So what I know is that this length is -3 and this length is -2. Now I can go ahead and I can use my Pythagorean theorem. R squared is equal to -3 squared plus -2 squared. So r squared is equal to 9 plus 4. R is equal to the square root of 13. So now I know all three of the sides of my triangle. Since I know that, I've drawn my terminal arm, I can determine my three trig ratios. So I'll just write SOHCAHTOA up here for you. So I've got sine of theta. Now remember, this is my theta right here. This is actually my whole theta, but we're using this for the triangle. So sine of theta is equal to opposite over hypotenuse. So a -2 over root 13. I have cos of theta adjacent over hypotenuse and tan of theta opposite over adjacent. And I'm going to rewrite that as just a 2 over 3. And now that I've done that, I can determine what my principal angle is. So I have my theta being this big angle, but I really just want to find my principal angle, so the little angle inside the triangle right there. To do that, I can use any one of these primary trig ratios. I'm just going to use tan because it's the last one that I wrote. If I have tan of theta equals 2 over 3, I can just say theta is equal to tan inverse of 2 over 3. So just like we solve an angle, and when I plug that into my calculator, I get 34 degrees. Now, because this chapter is all about terminology, I'm going to be keeping my terminology going here, and I'm going to be saying to you that this is the related acute angle. When we're solving simple equations like the last part of the example when I did tan inverse of 2 over 3, we are always supposed to get two answers. So our calculators only give us one, but we can use this new rule that we're going to go over called the CAST rule to find the second answer. So the CAST rule is something that you're going to be using for the rest of your high school career, and especially if you go into university. The CAST rule is using the quadrants, so quadrant 1, 2, 3, and 4 that I've labeled here. It seems a little strange because the CAST rule actually starts in quadrant 4 and goes counterclockwise. That's just something that you're going to have to memorize. What the CAST rule basically tells us is the quadrant that our second answer will be in. Now, all of this will make more sense as we go through examples. So C basically tells us that in this quadrant, anything cos will be positive. So we know that this is 270 degrees to 360 degrees. So if you did cos of 271, cos of 280, cos of 300, cos of 350, cos of 359, cos of any number between 270 and 360, you will get a positive number. Now it also means that sine is negative and tan is negative, okay? So the CAST rule just tells us which one is positive. In the A, you're probably wondering, well, what is A? I see a C for cos, an S for sine, and a T for tan. A means that all things are positive. So cos, sine, and tan of anything between 0 and 90 degrees will be positive. In quadrant 2, or S, sine will be positive, but that means that cos and tan will be negative. And in quadrant 3, or the T quadrant, tan will be positive, but sine and cos will be negative. Now, one more quick thing before I move on. I am going to be showing you how to generate the second angle, but I just want to write it here. You can write it on your page, that way you can refer back to it. In quadrant 2, I'll just draw in this terminal arm here. In quadrant 2, the way to get our related angle is going to be 180 minus, I'm just going to use a beta, that's just a Greek letter. And it basically just means that would be my angle, 180 minus this beta. In quadrant 3, it's going to be 180 plus beta, so my terminal arm would be there. And in quadrant 4, it's going to be 360 minus beta. Now again, this probably doesn't make sense, and it won't until we start doing some examples. And just a little reminder before we move on, you can write it on your note. When you're solving trig equations, always give 2 principal angles. All right, we're going to start our examples, and here's where it's really going to make sense for you. So solve. Sine of theta is equal to 0.47. Now we know on our calculator we can find theta simply by doing sine inverse of 0.47. Make sure your calculator is in degree mode, and you will get, when you round, 28 degrees. Now I'm going to think about cast here. I know that 28 degrees is right here, okay? Now in this quadrant, it's in quadrant A, so everything is positive, and that makes sense. This is saying sine of some angle must give me a positive answer. Obviously, sine is going to be positive in our A quadrant, but sine is also going to be positive in our S quadrant. So if I'm going to calculate the angle, the second angle that my calculator doesn't give me, I'm going to have to mirror this theta in my S quadrant. Now, I need to be following along with the x-axis, okay? So this will help me draw my angle. Now, if I know that this angle is 28 degrees, I can easily calculate my angle by doing 180 minus 28, and I get 152 degrees. Now, if you go back and look at your note, you'll notice that in this quadrant, in quadrant 2, I wrote 180 minus beta. That's exactly what I did here to calculate. So here you can visually see why, or you could just take a look at that formula that I wrote last time. So my 2 answers are 28 and 152. My next example is cos of theta is equal to negative 0.77. So this is saying cos of some angle is equal to a negative answer. So right away, I'm going to know that it's going to be in these 2 quadrants. Now I know that because here cos is positive and here everything is positive. So I know my answers are going to be in S and T. Now when I use my calculator, I'm going to do theta is equal to cos inverse of negative 0.77. And I am going to get 140 degrees. So my calculator is giving me this angle of 140 degrees. Now I know that that means my related acute angle, if this is 140, I know that this one's 40. Now when I'm trying to figure out the matching angle in the T quadrant, I need to mirror this related acute angle, and it needs to be touching my x-axis. So I know that if I want to get this new angle, it's going to be 180 plus 40, so 220 degrees. So my 2 answers are 40 and 220. My last example for this note is tan of theta equals negative 3.5, sorry. So tan of some angle is equal to a negative answer. Where is tan negative? Well, tan is positive here and is positive here. So I know that it's going to be in quadrant 2 and 4, or S and C. When I use my calculator to figure out the first answer, I'm going to get theta is equal to tan inverse of 3.5, and that's going to give me the answer of negative 74 degrees. Now, I'm not allowed to leave a negative 74 degree. That's a really not accurate terminal arm there, sorry. And so I need to rewrite this first angle right away as a positive. So when I do that, I'm going to be doing 360, take away 74, and I'm going to get a 286 degree angle. Okay, so this first angle is 286 degrees. I'm just going to throw that down here before I forget. Now, my second angle, I need to mirror it in this S quadrant right here. So I need to follow the x-axis, and I need to have a 74 degree angle, just like I had here, okay? And so if I'm trying to calculate this new angle, what it is 180 minus the 74. And that's going to give me 106 degrees. So I'm just going to use red, I guess, here. So just to visually show you again, this is 180 degrees. If I know this is 74 degrees, I can easily do 180 minus the 74 to get this missing angle. So 286 degrees and 106 degrees are my final answers.